We're going to talk about very briefly parallelograms. We already saw this in the last section, but I want to go over it and make sort of a flow chart, a very simple one, so that you can see where we're situated. So far we've studied three-sided polygons. We also studied what a polygon was. We've seen three-sided polygons, and when we talked about three-sided polygons, those were our triangles. And then we talked about our four-sided polygons, which are our quadrilaterals. And you know, you can have many sided polygons. You have the five-sided polygons, which are pentagons, etc. For four-sided polygons, we have our quadrilaterals. That's what we call them, quadrilaterals. And that's where we're at right now. For quadrilaterals, we can have two types of quadrilaterals. We can have our parallelograms, which was our last section, parallelograms. And we can have our trapezoids. And parallelograms is one big category, which includes, parallelograms will include rhombuses, and it will include rectangles, and rhombuses and rectangles include squares. Okay, so if I look at this flow chart, I can very easily see that parallelograms is like your big category for quadrilaterals, and inside this category you'll have rhombuses, rectangles, and squares. We already talked about parallelograms, and parallelograms are defined as two pairs of parallel sides. Rhombuses, since it's underneath the category for parallelograms, they also have this property or this definition. It's two pairs of parallel sides, right? Because it's a parallelogram. Rectangles have two pairs of parallel sides, and so do squares. And we discussed for parallelograms, we said that any parallelogram, here's a parallelogram, opposite sides are parallel. This is the symbol for parallel. We also said that opposite sides are congruent. We also said that opposite angles are congruent. We said consecutive angles are supplementary. That means if I label my vertices A, B, C, D, the measure of angle B plus the measure of angle C has to be 180. That's what it means when consecutive angles are supplementary. Also, the measure of angle C plus the measure of angle D is 180 degrees. Also, the measure of angle D plus the measure of angle A equals 180, and the measure of angle A plus the measure of angle B is 180. Okay, and the other thing about parallelograms is their diagonals. Their diagonals, which are the lines that join two non-consecutive vertices, this is a diagonal. And the other diagonal, the other thing about parallelograms is that where they intersect, right there in the center, the diagonals bisect each other. That means that diagonal D segment DB bisects segment AC, and also segment AC bisects segment DB. so they bisect each other. That means that this segment here is congruent to this piece here, and that this piece here is congruent to this one. Okay, that's what it means that they bisect each other. And these are the properties for parallelograms. That means that since a rhombus is a parallelogram, it will share all of the properties that parallelograms have. And so will the rectangles, and so will the squares. And that's what we're going to see in this presentation. We're going to talk about rhombus first. A rhombus, it's a parallelogram. That means it has opposite sides are parallel. But a rhombus, the definition of a rhombus is that all four sides are congruent. So we can see in this diagram, this side is congruent to that side, congruent to this side, and congruent to this side. That's a rhombus. And a rhombus is a parallelogram. That's what it says here. It's a parallelogram. So I know that for a rhombus, the opposite angles are congruent. The consecutive angles are supplementary. Opposite sides are congruent. And I also know that the diagonals bisect each other. An additional property for rhombuses is that the diagonals are perpendicular. So we can see in this diagram here that the diagonals in a rhombus, and I'm sorry for the squiggly lines, the diagonals of a rhombus, when they intersect at 90 degrees. And that happens everywhere. 90 degrees here, 90 degrees here, and 90 degrees here. Okay? So the diagonals bisect each other, and they also, for rhombuses, are perpendicular. Okay, that's one additional property to add to the properties of parallelograms. And here it says that a rhombus is a parallelogram, so it will inherit all the properties of the parallelogram. Let's see an example. It says use the diagonals of a rhombus. ABCD is a rhombus. Find the value of x. Here's x. And x is the value of this angle. Now, one important thing that you just learned about rhombuses is that their diagonals intersect at 90 degrees. So that means that this angle here is 90 degrees. Now, if I look at this piece of the rhombus, which makes a triangle, this piece here, it makes a right triangle. I'm going to draw this separate over here. I have a right triangle. This is a right angle. Here's my x, and here's my 60 degrees. If they tell you to find x, that means you need to find how much this angle measures. And since this is a triangle, I know that the angles inside of a triangle add up to 180. So for this triangle, I have 60 plus 90, which is the right angle, plus x, and the sum of those three angles have to be 180 because this is a triangle that I'm looking at. So this is 150 plus x equal to 180. And to solve for x, you would have to subtract 150 from each side of the equal sign. And 150 minus 150 cancels out. X is equal to 30 degrees. So this is 30 degrees here. And it makes sense. If I add all three angles, 60 plus 30 is 90, and 90 is 180. And there's your answer for x. In example 2, they give you the information of this rhombus. It says that this angle, the whole thing is 30, and that segment IH is 12. They're asking you to find segment FG. Segment FG is this segment right here, this segment FG. Now, since the rhombus is a parallelogram, I know that opposite sides are congruent, so this has to be 12 centimeters. This is equal to 12 centimeters. For letter B, the measure of angle FGH. Let's see where that angle is. FGH, if I trace FGH, that middle letter, that's the angle they're asking about. Now notice this angle is opposite to this angle, and I know this angle is 30 degrees. And for parallelograms, opposite angles are congruent. So this is going to be equal to 30 degrees. This is 30 degrees. For letter C, the measure of angle GHI. Let's trace GHI. Let's change the color of this pen. GHI. Let's trace it. GHI. The middle letter, that's the angle they want to know. Now, since this is a parallelogram, I know that consecutive angles add up to 180. So if this angle is 30 and this one plus 30 is equal to 180, I can write the measure of angle GHI plus 30 has to be 180 because they're consecutive angles. And I can solve for the measure of angle GHI by subtracting 30 from each side. So the measure of angle GHI equals 50 degrees. This is 50 degrees. And you could have done this using mental math. If this is 30 and you can say, well, 30 plus how much will make 180? Well, 150, then this has to be 150. 150, not 50. 150, okay? So 180 minus 30 is 150. For letter D, the measure of angle FJG, that's this angle here, FJG. It helps to trace it, that way it's easier to locate that angle. So we're talking about this angle that the diagonals make when they intersect, and we know that from the property we just learned about rhombuses. We said that the diagonals are perpendicular, so that means that this angle there is 90 degrees. Okay, and there you have that example for rhombuses. Here's another example. It says in rhombus FGHI, FG is 21, let's label it. Here's FG, FG is 21, that side is 21, FH is 15. That means this diagonal, this whole diagonal, that whole thing is 15. And the measure of angle FGH, FGH, this angle here, FGH, that's this angle. That angle is 70 degrees. 70 degrees. What is GH? Let's see. GH is this segment here, the side of the rhombus. And the definition of a rhombus says that all sides are congruent. So if side FG is 21, side GH also is 21. And so is HI and IF. They're all congruent. Okay? Here they're asking for HI. HI is the side of the rhombus, and we just said that all sides are congruent, so this is also 21. FJ. Let's see, FJ is the point from here, sorry about that, from here to here, FJ. I know what FH is, the whole thing. FJ is half of the whole thing because I know diagonals bisect each other in a rhombus. So half of 15, that would be 7.5. For JH, JH is the other half. And since this piece is congruent to that piece. If this is 7.5, this has to be 7.5. The measure of angle FIH. FIH. So we're talking about this angle. That angle is going to equal what the opposite angle equals. Remember, this is a parallelogram, so opposite angles are congruent. So this angle is 70. That means this one has to be 70 degrees also. Measure of angle GFI. GFI. That's this angle here. GFI. That's this angle. Okay? Now, since this is a parallelogram, I know that consecutive angles are supplementary. Consecutive angles are supplementary. That means that this angle plus this angle equals 180. So let's write that. The measure of angle GFI, that's this angle, plus 70, that's plus this one, has to be 180 because I know that in parallelograms, consecutive angles are supplementary. And now we solve for the measure of angle GFI. If I subtract 70 from each side, I get 110 degrees. Okay? 110 degrees. For the measure of angle FJG, FJG. Let me change colors again because I have a lot of red here. Let's do blue now. FJG. They're talking about this angle. And that is the angle of the diagonals at the intersection point, and we know that the diagonals are perpendicular, so this is equal to 90 degrees. And for this one, HJI, angle HJI. So we're talking about this angle. And this angle is also 90 degrees, both by vertical angles here, and also knowing that the diagonals are perpendicular in a rhombus. And there you have that other example. Here's another example for a rhombus. Find the value of x. I have to find what x is. And here they're showing me that this side measures 3x and this side measures x plus 2. And they're telling me it's a rhombus. Automatically for a rhombus, I think, well, all sides are congruent. That means that this side measures the same as this one, the same as this one, and the same as this one. So I'm going to state that fact in an equation. I know that this side, which measures 3x, is equal to this side, which measures x plus 2. So I'm going to write that 3x is equal to x plus 2. And what I'm saying is that that side is equal to that one by the definition of a rhombus. Now to solve this equation, and notice I always say this in class, this is where geometry stops and algebra starts. All I used from geometry was the fact that this is a rhombus and that all sides are congruent, and I wrote an equation. From this point on, it's all algebra. So you need to be very, very sharp with your algebra skills. When we solve this equation, this x on that side of the equal sign, I need to move to this side. And the way to do that is by subtracting x on each side. 3x minus x gives you 2x equals, and then x minus x, that cancels out and you keep a 2. X is equal to 1. If you divide by 2 on both sides, you get x is equal to 1 because 2 over 2 is 1. So you found x. And that's all the problem asks for, is to find x. But I can go a little bit further and I can ask you, tell me what this segment measures. How much does that measure? Well, it measures 3x, okay? But I just found x, so how much does it measure? Well, 3 times whatever x is, which is 1, so it measures 3. And how much does KL measure? Well, it measures 3 because this is a rhombus and all sides are congruent. Okay, so there you have it. I hope you understood all of these examples. On my next video, we'll talk about rectangles. I'll see you then.